GCSE Physics boosters, speed and velocity. This is the first video in the Forces and Motion playlist, which is the second half of Forces, and it's another big playlist. Anyway, some basic stuff here, speed and velocity. Okay, Harry the hiker, there's Harry, goes for a walk, and it takes him 20 minutes, and he starts at A, and he ends up at B. So the distance between A and B is 800 meters, but the actual distance that he travels is about 2 kilometers because he goes for a nice little wander all around the place. So here are some questions. Distance traveled, displacement, average speed and average velocity. So pen and paper, write them down. I'll show you the answers in 3, 2, 1. Distance traveled, 2 kilometers. And that's different from his displacement. His displacement, 800 meters east. Now why? I've already talked about scalars and vectors, and displacement is a vector. It has direction. He ends up 800 meters east from where he started, so that is his displacement. The distance traveled, however, is 2 kilometers. His average speed is 1.7 meters per second, and that is 2,000 divided by, how long was it? 20 minutes, so 20 times 60, 1.7 meters per second. His average velocity is displacement over time. So that's 800 meters divided by 20 times 60. And again, speed is a scalar, doesn't matter what direction you're traveling in, whereas velocity, to get its average velocity, you draw a line between the start and the finish. You look at the distance traveled or the length of that line, yeah, and then divide that by the time. And that tells you the average velocity. Okay, displacement and velocity are vector quantities, and we should give a direction, unless it's obvious in the question what the direction is. For velocity, we should give a direction. Now, on the last slide, I said the average speed and the average velocity. Why did I say average? And the answer is because it's possibly changing all the time. He might not be walking at a constant speed. Yes? At this point in time here, at t equals 3 minutes, his speed is 2 meters per second. That is his speed at that point in time. At that point in time, his velocity is 2 meters per second northeast. That is his velocity at an instant. We say there's two velocities. There's average velocity and there's instantaneous velocity. And his instantaneous velocity at that instant is 2 meters per second northeast. Okay, his speed at t equals 3 minutes at that point in time is 2 meters per second. His velocity is 2 meters per second northeast. Interestingly, the magnitude is the same. Okay, the magnitude of his velocity at any instant is equal to his speed at that instant. This is a list which you should learn. You might be asked it in an exam. Typical values for walking, 1.5 meters per second. Obviously that's going to depend on an awful lot of things which I'm not going to talk about because I think they're obvious. Running is about 3 meters per second unless you're Usain Bolt. Cycling about 6. Car on a motorway is about 30 meters per second, maybe 35. A fast train about 50. The speed of sound in air is about 330. In another video, I talked about how you would measure that. Okay, again, that's not fixed. It can vary. It varies a little bit with temperature, with air pressure, with humidity. It's about 330 meters per second. Learn that list. How would you measure your walking speed? How would you measure the speed of cars going past your school? You know, how many of them are breaking the speed limit? Well, to measure speed, usually we measure a distance and we measure time. Okay, depending on the distance involved, whether you use a ruler or a tape measure, you know, and time, depending on how accurate you want to be. Okay, but you measure a distance, you measure a time, and then speed is distance over time. Now, motion in a circle, it's a special case. Later on, we're going to talk about satellites. Satellites are an example of something moving with what we call uniform circular motion. Now, this ball is moving in a circle and its speed is constant. The speed of the moon going around the Earth is approximately constant, but its velocity is changing all the time. Now, why? Because velocity is a vector. And if you look at the arrow, which shows the direction of the velocity, that arrow is changing direction all the time. So its velocity is changing all the time. We will ask a big question later on. Is the ball accelerating? I'll talk about that later. Here's a couple of questions for you to have a go at. Some of them pretty straightforward. Get a little bit trickier later on. If you get all of them right, then you're doing well. So pen, paper, calculator, work them out, pause the video. I'll show you the answers in 3, 2, 1. There you go. Right. Now, why? Well, let's have a look. So it's speed. Now, speed is just the distance traveled divided by time. Now, the distance traveled is the circumference of the circle. And the circumference of a circle is 2 pi r, you should know. 2 pi r divided by the time it takes to do that, which is 10 seconds. So 10 pi divided by 10 is pi meters per second. 3.14 meters per second. That's its speed, which is constant. So I don't need to say average. Its velocity at point A. Now at point A, its speed is pi meters per second in that direction at that point in time. So its velocity at point A will be pi meters per second west. And at point C, its velocity will be pi meters per second east. Now it gets a little trickier. Its average velocity from A to C. Now from A to C, what we do is from A to C, if I draw a line there, that's its displacement from A to C. That distance is 10 meters because it's 2 radii. It takes 5 seconds to do that because it takes 10 seconds to go around once. So its average velocity from A to C will be 10 divided by 5, which is 2. Okay. Then lastly, and if you got this one right, I am very impressed. Its average velocity from A to B. Now from A to B, its displacement is that. That's its displacement. Okay. Now what is this distance here from A to B? Well, if that's 5 and that's 5, then you should from maths know a bit about Pythagoras. Then this distance from there to there is going to be root 2 times 5. Yeah, sorry, beg your pardon. 5 root 2. 5 root 2. Yeah, Pythagoras. That squared plus that squared equals that squared. Yeah. And the time it takes to get from A to B is 2.5 seconds. So it's 5 root 2 divided by 2.5, which is 2.83 meters per second southwest. If you got that right, well done. Its average velocity from A all the way back to A is 0. That's crazy. Why? Because its displacement is 0.